Hey everybody. So I said my first video was going to be about slope and grade. So this is the worksheet that's titled that worksheet on slope and grade in Blackboard. And what we're going to do is see if we can take notes directly on here. So I just want to zoom in a little more. Here we go. So it says, is the directions in the following examples, calculate the slope of the surface. Convert your answer to a grade by converting the slope to a percentage. So before we do that, we need to talk about slope. So think about in real life where you might hear the word slope. When I think of the word slope, I think about skiing right away, okay? Because we ski the slopes. So what is that referring to? That's referring to the mountainside. That's referring to how steep it is, because we know that beginner skiers would go on what they would call like the bunny slopes, which are much more gentle. And the more advanced skiers are going to go on really steep slopes. So slope is referring to how steep that surface is. And that could refer to any kind of incline or decline. So that's what we're going to see here as our definition. Now, go one step further. Think about what makes something steep. So when you're climbing a set of stairs, what two things cause the stairs to be thought of as steep? Well, it depends on how tall each stair is, but it also depends on how wide each stair is. And that's what's going to determine how steep those stairs are. So what we say for slope is we call that rise over run. So how tall the step is divided by how deep the step is. So vertical over horizontal. That's what we're talking about for what determines a slope. Think about how you naturally step with your foot. You have to raise your foot first. So rise comes before run, okay? So now let's get into some of these examples. So I'm going to annotate this as we go. Before I do that, let me just scroll down so that we can see all the examples at one time. Okay. Maybe I should zoom in a tiny bit more. See if we can see them all at one time if I do this. Okay, good. All right, so you can see we have a staircase here. I was just referring to a set of stairs. It has a vertical distance of 8 inches and a horizontal distance of 11 inches. And so that would tell us that our slope is rise, which is 8 over 11. My slope here is going to be 8 over 11. Now, grade is simply slope converted to a percent. So, how do I convert something to a percent? It's going to be rise divided by run first, and then times 100. So I'm going to do that division, and then I'm going to multiply by 100. So this is where I use my calculator. I'm going to do 8 divided by 11, and then I'm going to convert that to a grade. So you can use your calculator for that. I don't know what 8 divided by 11 is off the top of my head. So if I go into a calculator, 8 divided by 11, I get 0.727272, okay, repeating. I'm going to obviously be rounding that, but first I'm going to multiply by 100. So if I multiply that by 100, or in other words, move the decimal point 2 places, I'm going to get 72.727272. So what we're going to write here is we're going to write 72 72.7%. Okay, now we rounded that, so I'm going to put the approximately symbol in front. So now I know that it's approximately 72.7%. So that's the steepness of that staircase. Now let's take a look at this mountain. This mountain has a rise of 1,200 feet, and it has a run of 1,300 feet. So vertical direction, 1,200 feet, horizontal direction, 1,300 feet. If I put rise over run, then I'm talking about 1,200 divided by 1,300. Now, to simplify that fraction, I can cancel out the zeros, and this becomes just 12 over 13. So if I was just writing it as a slope, it would be 12/13. But if I convert that to a grade, 12 divided by 13 is 0.923 and change. I'm going to multiply that by 100 or move the decimal over 2 places, and I get approximately 92.3%. So now let's put this in perspective. What would you expect to be steeper? Would you expect a staircase or a mountain to be steeper? Well, I would suspect that a mountain is steeper. And now we can compare the two grades. This had a grade of 72.7 or almost 73%. This has a grade of 92.3%. So the mountain is steeper because it has a higher grade. Why is this stuff important in real life? Well, when you guys do any kind of building, when you have building codes, which we're going to see a roof in the next example, they have certain restrictions of how steep things have to be. Okay, they have restrictions about how steep a staircase has to be for safety. They have restrictions to how steep a roof would have to be. So all these things are policy driven, and so you would use that in real life. This is the concept of slope in real life. So now let's do the roof, and then I'm going to leave the other two for you guys to try on your own. So let's do the roof. I have the height of the roof being 5 feet. I have the run of the roof being 12 feet. If I stick to my rise over run, this is going to be 5/12. 5/12 would be my slope. That doesn't really tell us too much in terms of real life. So I'm going to go to my calculator and I'm going to do 5 divided by 12. And I get 0.4166666 repeating. So I multiply that by 100 or move the decimal over 2 times, and I will round the 0.666. So I get approximately 41.7%. Okay, again, put the 3 that we just did in perspective. What would you expect to be the steepest? What would you expect to be the least steep? I would expect a roof to probably be the least steep, and that had the lowest grade so far at approximately 42%. Okay, so I'm going to leave the other two for you guys to do. So this is a moving van ramp with a height of 2 feet and a width of 7 feet. And this is a handicap ramp, a height of 3 feet, and then a run or horizontal distance of 25 feet. So you guys should be able to work that out. Okay, so now continuing on with this concept of slope, now we're going to take it out of the real world and we're going to put it back to math. So we're going to bring it back to our graphs. Okay, here I have 2 graphs, okay, and we're going to do a comparison when we do these. And you can see that I have visible points on this line. So I can see where I'm going to start and I can see where I'm going to be walking to. I tend to use this concept of walking the line to make this more concrete. Pretend this is a big map of a city, okay? These are all city blocks. I'm going to need to tell somebody how to get from this first point, the leftmost point, to the rightmost point but they can't directly walk on this line. If I was going to tell them how to walk on city blocks, I would have to tell them, oh, go up 2 blocks and go over 3 blocks. The same concept of rise over run. So I can see that here, if I fill this in, I can physically walk up 2. So this would be an increase of 2. And then I'm going to walk over 3. And so this would be a run of 3. And so when I set up my slope, I have a slope of 2/3 because I went up 2 and to the right 3. For now, we're always going to walk to the right, okay, because that's going to keep our increasing and decreasing straight, okay? So we're always going to go from left to right because that's how we read graph. Let's do the same thing for this one. I'm always going to walk from left to right. So I'm going to start at the leftmost point, which is here. This is the obvious point. And I'm going to walk to the rightmost point, which I can see this point here. How am I going to get there if I was giving somebody directions? I'm going to go down this time. I'm going to go down 2. Well, I have a problem. I have to describe that as going down. The way we're going to describe down is minus, -2. Okay, that shows us that we went down. So I'm going down 2, and then I'm still going to the right 3. So what does that make this slope? That makes this slope -2/3. Okay, look at the difference between these two graphs. In terms of their steepness, these two graphs are actually the same steepness, okay? 2/3. How do we determine which one is uphill and which one is downhill? We determine that from the sign. Increasing lines have a positive slope, and decreasing lines have a negative slope. And that is always going to be true, okay? So the question that I have here to kind of guide us through that is, what is the difference between these two graphs? This graph is increasing. This graph is decreasing. How can we show that difference in their slopes? This slope was positive because I was going up. This slope was negative because I was going down. So that's always going to be the relationship. So increasing lines have positive slopes. Decreasing lines have negative slopes. Okay. Moving down the page. I have 2 more graphs. Again, doing them as a side by side. We're going to do the same thing. We're going to walk these lines. If you were being asked to walk these lines from left to right, how are you going to do it? Well, I'm going to start from my leftmost point. I want to get to my rightmost point. I have to go up 1, 2, 3, 4. So I'm going up 4, and I'm going to the right 2. So what does that mean for rise over run? That gives me a slope of rise 4 and run 2, rise over run. But I can simplify this. 4 divided by 2 is the same thing as 2/1, or just 2 if you wanted to get it to be a whole number. But let's look at it as 2/1. This way we can still see rise over run. This means I can also go up 2 and to the right 1, and that's the same movement. So let's see if that's the same movement. I should be able to go up 2 and to the right 1. Look at that. I did still hit the line. Up 2 to the right 1. I still hit the line. Up 2 to the right 1. I still hit the line. So this is your constant change, okay? This is what's happening as you go up the graph. Now let's compare it to this one. How am I going to get from the leftmost point, which is here, to the rightmost point, which is here? Visible point, I should say. So if I start here, I'm going down 1, 2, 3, 4, 5. So this will be a -5, as we saw above, because I'm going down. And then this is just to the right 1. So this gives me a slope of -5 over 1, or just -5 if you wanted to get it back down to a number. But again, let's compare these two graphs. Here I had a slope of 2, positive 2, because it was increasing. Here I had a slope of -5, negative because it was decreasing. But which graph is steeper? This graph is steeper. Okay, I know one is increasing and one is decreasing, but this graph is steeper. So look at the magnitudes of the two slopes. This slope is just a 2. This slope, if you ignore the sign, is a 5. And so yes, this graph should be steeper because the size of the slope, ignoring the sign, is larger. So that answers this question. What seems to be the relationship between steepness of a line and the slope? The larger the slope in magnitude, ignoring the sign, the steeper the line. Okay, I hope this is all making sense so far. So now let's go down to the exercises that follow this on this packet. The directions say, create the appropriate graph on the accompanying graph paper using the given point and the slope. And then you can ignore the rest because we're not doing this in class. So let's do number 1 and number 2 together, and then I'm going to leave the rest for you to do. Okay? So number 1 says, draw a line going through 0, 2. So it's giving us a starting point. I'm going to have to plot that point first. And then it's giving me a slope, which are directions. This is my rise, and this is my run. Okay? So I have to go through 0, 2. That's giving me a starting point with a slope of up 1 and to the right 3. Okay? So 0, 2, and then up 1 and to the right 3. So let's go to our graph paper. First, I have to make my axes. So I'll make my x-axis, and I'll make my y-axis. Okay. And we know we can increment these 1, 2, 3, -1, -2. I'm not going to go too crazy here, especially because of my capabilities. And then this is -1, -2. So this told us to go to 0, 2, 0, 2. That's right here. So I'm going to do it in a different color so we can see what we're doing. This is telling me to make a dot at 0, 2. And then it's giving me a set of instructions. It said to go up 1 and to the right 3. So from here, I'm not going to make any markings. I'm just going to follow the directions. Up 1 and to the right 1, 2, 3. Then I can make another dot. If I wanted to do one more point just to make it go into pattern, I can do it again. Up 1 and to the right 3. Make another dot. You can see that that's what's causing the straight line. It's that constant change that we talked about the other day. Now I can connect the dots. And I can extend my line. And that's what the graph should look like. Because again, it should be maintaining that up 1 and to the right 3. So make sure, up 1 to the right 3. Up 1 to the right 3. Once you get really good, you can reverse the direction and then move backwards to the left, but only when you get really good, okay? But a positive slope should mean that it's increasing from left to right. All right, I hope everybody is okay with that. So now, unfortunately, I have to clear, otherwise it's going to stay on the screen. So I'm going to clear this drawing, and we're going to do the second one together, and then I want you guys to do the rest. The second one is draw a line through -3, 5 with a slope of -2/3. Okay, think about what that slope means. That slope means it's going to be decreasing, negative. So down 2 and to the right 3, starting at the point negative 3, 5. So I'm going to go down to the second space on this graph paper, and I'm again going to make my axes. So I have my y-axis, I have my x-axis. I'm not going to go too crazy here with tick marks, but I'll label a few. Here's 1, 2, 1, 2, negative 1, negative 2, negative 1, negative 2. Okay, you can of course make that look much nicer. All right, and then we're going to plot points. So let me do this with a different color. So the point they wanted me to start at is negative 3, 5. So negative 3 would be here, 1, 2, 3, 4, 5. So here's the point, negative 3, 5. The directions told me negative 2/3 was my slope. So down 2 to the right 3 from here. So 1, 2, down 2 to the right 3. This would be my next ordered pair. Keep following it. Down 2 to the right 3. This would be my next ordered pair. I could even keep going. Down 2 to the right 3. This would be my next ordered pair. And then I can go in and I can connect the dots. And that would be our line. Okay, so I hope this video makes sense. You'll be seeing a lot more with slope and the connection to our linear discussion in our next video. All right, have a wonderful rest of your day, and always keep in touch with any questions.